request Rashekar Malgihal sir to present a bouquet. It's our opportunity to hear from sir the technical talk, production of strength of building components using machine learning techniques. So now I request Dr. Santosh Malkapur sir to introduce today's resource person. Sir, please.
Good afternoon, everyone. So, indeed, it is my honor to introduce such a wonderful speaker. I just called, I gave a call, and sir readily agreed without. Actually, we had a MTech House examination. Within just 2 days, sir has come. I wholeheartedly thank him for coming here and gracing the occasion. And to tell about sir, I think it is not a small job, because such a wonderful researcher. People say it is very difficult to do a patent in civil engineering. I have heard from many senior professors. Sir, in sir name, as of now, 17 patents have been filed. 17 numbers, just a number. And he has so many years still of his research pending, and sir has completed six projects, reputed projects for DST and many such eminent organizations funded projects. And sir is also inventor to many new novel concretes, to name a few, glasscrete, and recent work is can you think of a battery out of a concrete? So concrete battery they have done. That was a recent work of sir. So maybe next time when he comes, he will be presenting that. So many such wonderful works sir has done, and he has under his supervision 11 PhDs have completed and 6 are pursuing. And his area of research include development of sustainable material for structural application, microcharacterization of concrete, and machine learning. And he has 126 articles, technical articles, and 184 keynote lectures, and many funded projects by AICTE, CSIR, DRDO, and DST, and has secured projects from DST and DBT, Department of Biotechnology, Science and Technology now. And sir has received 17 awards. How many? 17 awards, including the most esteemed award of Vishwakarma Award in 2018 by Planning Commission of India, so New Delhi, and Best Faculty Award 2017, and Bharat Ratna Mother Teresa Award 2014, and Dr. APJ Abdul Kalam Award 2015, to name a few. And the Indian Concrete Journal honored him by Outstanding Young Concrete Engineer title. So we are very fortunate to have sir here addressing us. So thank you sir for kindly coming us and gracing the occasion. And now the stage is yours, sir.
Dear friends, good afternoon. Yeah, my time is around 35 minutes only allotted for me. After I finish. Don't worry about that. No. Our components using the machine learning techniques. So most of the people are talking about the machine learning, artificial intelligence, so on, so like that. So why we are not civil engineers, we cannot use for this kind of technology for our applications. It's not a new, but the people are keen the previous itself, but now it's a trend. Are people using that machine learning and a neural network and so on, so etc. So here how I start this work means due to the corona time. Previously, basically I'm a structural man. Did a lot of around 8 PhD was completed under my guidance, in particularly beam column joint only. Previously, I never touched any kind of machine learning, any material science and all those things. So after corona, my lab fully closed. That time we are thinking what we want to do then. So again, recollect our PhD thesis with the previous researchers. We sitting together. We start. Why not we change this experimental part with respect to machine learning? That is the point. So recently we start this work. So first I sincere thanks to my previous research scholars, and a special thanks to my MTech research student, Shreyas Arvind. So here, when you need for that AI and artificial intelligence, neural network and so on, so machine learning algorithm, so the constraint is more. Constraint is more. For example, I simply tell you, most of the third year final year. So take the simple supported beam, the UDL, I think W per meter run. You know that what is the bending moment, where is the bending moment, what is the bending moment, W square divided to mid x, right? So an expand. So there is a simple mathematical model is given to you, calculate what is the bending moment. Similarly, I can change the load. First, for example, length L by 10th, L by 8, L by 10, L by 4, L by 6. I change the intensity of the loading. Some complications, right? You cannot solve W square by 8 very easy, it's correct. Again, I can change the depth or geometry. Again, I introduce some point load or incline load. Again, point load, couple, moment, so on, so things, very difficult. You are rendering some additional equations to solve the problem. Correct, no? So the simple concept. Suppose my constraint is more number, n equal to something, 100, 200, like that, how we can solve? Very difficult. For that, we have some numerical method and analytical method. So from this is one of the method. So you can solve this complex problem. So here, I took only the beam column joint in expressly, in the particular, I taking for beam column joint. Why? Because during the earthquake, this is a highly vulnerable joint because of brittle nature. So more shear strength is occur in the joint. So due to the cyclic loading effect and all, the more shear strength accumulate in the particular joint, it becomes a brittle in nature. So what do you know that if it is a metal is a brittle, what will happen? Immediately failure, so collapse will be happen. For that, we are concentrating more about that beam column joint. How to improve the beam column joint with respect to change the reinforcement and with respect to change this material. I want to change this property of material in the particular joint. Then I want to change this externally, internally, and a mechanism formation. Lot of method is there. I don't want to take much more. Here I am focused about that, particularly beam column joint. How to predict the shear strength of the beam column joint. That is a complex task, and also some simple formula available. That I am not satisfied with this formula. I am not satisfied formula. For example, take your classroom efficiency. Your classroom efficiency find with respect to only CGPA, right? Nowadays NEP also introduced, no? Not only CGPA, you have to consider for the fine arts, then your curricular activity, extracurricular activity, and all those things. Is correct? So this is the, now it is defined as this is the right method to assess the quality of your degree. Similarly here also, we have, even though we have some formula to find what is the shear strength of the concrete or the beam column joint, it is not enough for me. It's not 100% too suited for my. What is the formula finally I can get? This is the basic outline of today's talk. Right. Now, these are the earthquake you are seeing in most of the places. Right. What is the problem here means? You can see here. This is the particular beam column joint. Column. This is the beam. Suppose you take this joint, this junction. Column, beam, slab kind of things. So the column, nothing happens, is correct. So it is strong in nature, is right. In the beam also is not an issue, but in the beam column joint is the problem. You see here? There is the problem. We want to take more concern about that beam column joint. Once you make it as a strong or the ductile in nature, it is a protect the structure from the earthquake. That is the possible. Here also same scenario. Now, what is the theory? Lack of availability of holistic numerical models and the depth of treatment in the standard text. Most of the familiar friends, you know that. Video missing, no problem. Right. Most of the funnel here, maybe know about the rules after the application design structures. So you know that the beam strength less than the column strength. Most of the people are aware about that. So right, because what is the need of? Why the column strength is greater than beam strength? If column failure first, you cannot escape from the building, right? This is the philosophy, right? So the beam strength is less than the column strength, or column strength greater than the beam strength. Then another philosophy is the joint strength is greater than the column strength. Joint strength is greater than the column strength. We are working in the new concepts. The strongest joint, strongest column, weak beam design. This is new area we are working. We make it the strongest joint. Then column, weak beam design. For this, I need some new parameters, I need some new formula to calculate this strength kind of things. So why we go for machine learning and now you look at the beam column joint, we have a huge number of forces like a shear forces, then moment, then horizontal shear, the vertical shear, so a number of forces right here. Here you see this particular joint, very difficult to find. So right, I given this problem to you, you cannot solve easily with respect to formula W squared by H. It's very difficult. Right. So here this is the basic shear force and bending moment diagrams. This is a more complex in nature, in particular beam column joint. So in addition that we have the number of theory to calculate the column shear, joint shear, so on so like that. I will come to the next topic. Now here what is the problem basically I am pointed out here means more number of complexity in interior and exterior or corner, beam column joint. It's have that some horizontal shear, tension, compression, then vertical shear and the compression and so on so things, lot of things is involved here. Again, suppose you take the beam column joint, it's not only with respect to the force, it may be with respect to the concrete strength, FCK for example. Again, what are the reinforcement inside the beam column joint? Reinforcement means in the column reinforcement, beam reinforcement. In column reinforcement also, longitudinal reinforcement and lateral ties. Again, beam, bottom reinforcement, top reinforcement or singly reinforcement, double reinforced and stirrups, bend up or so on so, etc. Again, the bonding between the reinforcement and the concrete. Then geometry and how its coincidence or how to join this column and beam. That is some is exactly connected or eccentric connection, so on so things. Then beam column joint, this is the column, this side on beam, this side on beam, same length, same intensity of load is not an issue. The different load, again, the moment, unbalancing moment will be happen. So this one side. Another one side is in plane bending moment, out plane bending moment. In this direction also have some torsion, twisting kind of things. So in addition, we add some load from the wall or external load or impact load and all those things. So n number of factors involving here. This is so for this we going for machine learning or a new kind of thinking. So just I take 1 minute regarding that. What is the difference between that machine learning and our calculators, right? Calculator and all those things. So suppose you want to multiply 2 into 2 equal to. So 2 into 2 equal to 4. So this is a simple case. I give the command inside. It's 2 multiplied by 2, then 2, you can get that 4. That is the answer. The calculator do like kind of things only. Similarly, what is a machine learning here means I'll give this same kind of things. I give the data. With the data, for example, today morning myself and Santosh sir planned for walking in our around the campus. This is mine. This is Santosh sir. Right. So, finally, I want to find what is the walking ability of mine and Santosh sir combined effect. So, what is this? So, it's a Palaniswamy have the n number of factors. For example, my height is a factor for my output. Is correct. My weight, my height, my physical fitness. Yesterday, I slept or not. Full night travel. Right? I had a 6:30. My dinner. So these are the my factor. But Santosh sir, he also not slept. 5 o'clock he called me. That factor. Then physically it's brisk because he is coming from nearby. He had some home food and also he had with me also. So n number of factor. In addition that, this is my new place that in fact for this old place. Right? So sometimes the new place is more enthusiasm to walk more. That also factor. Again, road surface, the nearby, student face, old friends, new friends, etc. So this around I take x1, x2, x3, x4 like this. For Santosh sir, I take y1, y2, y3, y4 like this. I want to make the relations between my and Santosh sir. Finally, I get that matrix. So this is called as the basics of machine learning. Basics of machine learning. Finally, I can get. So 2 into 2 it's a command. Here data. Data is a given. So you can use more number of data, you can get more number of very accurate results. And you give the more irrelevant data. More irrelevant data also, it's bad. Some results comes.
Is this called the training which we say in the machine learning?
Yes.
Training the data.
Yes, come. That's what I will come. Yeah, that is kind of things. We give the data. Data is put inside this. So finally, how it's processed inside. Different algorithm is there. I take only particular algorithm. Here this is the basic mathematics. Most of the people know about that. How I can get that one line, the trend line. It is the basic. So we have the n number of coincidences for Santosh sir and myself. No, get that scattered. I can get an equation y equal to mx plus c. That is the equations giving the representation of two datas. So it can reference a different way. Polynomial, cubic polynomial, algebraic polynomial, straight line according to our convenient, according to our accuracy and all those things. That's right. So this is the basic. From this we develop. These are the some terminologies: label data, algorithm, hyperparameters, so on so kind of things. Here, as our peripherally I go, I am not going deep, right? So we are using the different learning. What is the learning means? 2 into 2 is a 4. Is equal as the only command. You can give the n number of data. The machine will learn. What is the previous one? Like a ChatGPT. Same concept here also, right? It's learn. What is the previous one? Suppose today any match now, you can give that one approximate score also possibilities, right? What you will win the match, right? With respect to previous record, right? Guess is some. Suppose you take this now. This is a pointer. How you know this pointer? How you know this is pointer? Your mind trained previously. This image is stored in your mind. Compared with these previous images, you can come to the know. This is the pointer. Similar kind of things. Here, 2 or 3 concepts we want to know about that. One is a supervised learning, unsupervised learning, and reinforcement learning. So here, when you go for supervised learning means, for example, I can take the beam, right? So what is the bending moment? I know, W L square by 8. That is a known, right? So that is a known factor you can do for the supervised learning. Unsupervised learning, for example, you take the river. Water is flowing from the Madikeri to Bay of Bengal. We are unable to know about that. That is a endless. Then we under cloud, moving one place to another places we cannot predict where it is maybe some kind of place. That is called as a unsupervised learning. First one is this classroom teaching. This unsupervised learning is the corona time teaching, right? I am in my place, you are here, you are learning something. Then reinforced learning like a tutorial class. I will give a problem to you, you solve the problem, 2 faculties come and I see your answer where it's stucking. Any stucking means then give the exact track, let's go there. For example, games theory and all, playing this one. So here, why we are supervised learning means we know that what is the predicted, what is the strength of that beam, column, joint, so on, so we are using for the supervised learning. Then different approaches we have. Here I have different approaches. They are using for green regression, then regression analysis, SVM, KNN, number of. So we are using for ANN, artificial neural network. It is useful to address the problems where the solutions are not clearly formulated. So different algorithms, you can just to Google it, you can get more. That point given to you only. Does not relate to predicted preconceived theories describing the mechanism, and is get very good results in compared to others also. That's why we are choosing ANN. Then any ANN, we have some data set is needed. Data set, sorry, is pointed out, no? Data set is needed. So how we can take the data, choose the data, and how to retrieve the data, this is another part. Then these data, how to train this our model, that is another process. We can get some results. From the results, how I can predict the one mathematical model or with mathematical with respect to some coefficient all. That is another art. So I want to take up here. Then any model have some restriction, any model have some limitation also. Similarly, you can develop any kind of model possible. Here I took only the exterior beam column joint. I shown that figure in the beginning. Interior beam column joint, exterior beam column joint, so on. So I took only the exterior beam column joint. The spacement with eccentricity between the beams and column is avoided. This is exactly coincidence with the CG of column and CG of beam. The final failure modes will be joint shear failure. Then again you take this beam column joint, different types of failure is there. Okay, beam failure, beam column joint, then combined hinge, n number of failure is there. I took only consider for the final failure modes will be joint shear failure only. Joint shear failure only. Otherwise, I take unnecessarily more number of data. My output, that model is not good. For example, I unnecessarily add more number of data for efficiency of my walking. Again, my result somewhere is there. It's not relevant for that only. Then, while constructing database, the following data is investigated and collected. So, what is the data is considered for my beam column joint? This particular my problem only. One is the scale and nature of the specimen, and width and depth of the beam and columns. Width and the depth of the beam and columns. The number, diameter and grade of reinforcing steel bars in the beam, top and bottom, corner, interior, location, so on. So, I consider the number, diameter of reinforcing bar details and length of the beam from the joint face, then grade of the concrete I taken for my model, the details of shear reinforcement at joint location, column axial load level, that's the case, and failure mode. So these are the parameter consider for my model. So already told already this model is available to predict the shear strength. For example, ACA, American Concrete Institute, 3522002, they consider these are the factors. One is the compressive strength of the concrete, joint factor for the type of the joint. My argument is these 3 is not enough, these 4 is not enough. You want to add something, don't want to add more, but some limitations you want to add. Now what is the efficiency of our formula? That is our aim. Then EN code, joint width they consider, joint depth they consider, column axial load, the reduction factor for compressive strength, factor for design value of tensile, strength, so on, so etc. IS code 3 only is the compressive strength of the concrete, joint width and the joint depth. 3 only is considered. Right? This is my argument. It's not enough to predict the
joint shear failure, this kind of thing. New Zealand code also same kind of things. My proposed model is consider these are all the factors, right? Joint width I will consider, joint depth, compression strength of the concrete, beam reinforcement, top, bottom, beam length, yield strength of the beam bars, that is the yield strength of rod, the joint shear. Joint shear. So already told you know. I know that output means I go for supervised learning. I take the joint strength. It is a joint shear is the final product, final end product. That also consider here. Then reinforcement index, then column axial load level, beam bar index, and also we will consider here. Now these are all the notations how I can change this geometrically. These are the things here. Here. These are the joint shear reinforcement index, how the column load I can take in. These are the some mathematical background. Or otherwise, how I know that computer know? You don't say numerical only is correct. For this, we took this kind of things. Here, this is my database. Any model, the database is required. Then only the machine can be treated. Then this is statistics data for my model. The